Hello everyone, in this video, we're going to look at how to create your first circuit in Tinkercad. This is called Blink. So for Blink, we will start by, of course, opening our browser and then going to the Tinkercad website. And then if it doesn't immediately show up to your main dashboard or profile, you just can click log in or sign in. So in this case, we'll create circuits. Over to the left side, create new circuit. It'll take a while. There. As you can see, there are pre-made circuits built from under starter, so you can always explore that. Same thing with Arduino IDE. It has programmed basic operations and challenges, and it utilizes most of the parts, especially for starters. So first you need to change the title of the project. So I'll put project 1 like that, blink, hit enter there. And then in this case, you'll basically create the virtual setup of the circuit. So you can click search Arduino R3, click the image and then just drag it here at the middle. You can always scroll up and down here if you want to. The Arduino, the name of the board, you can leave the name 1 or type or blink, something like that. All changes have been saved. So this is an actual live file. Remember, your connection must be stable, right? So the next part is adding the components. So for blink, you need the LED. You can change that to a desired color. I would choose yellow. Also a resistor. For resistor, we will use fairly low resistor in ohms. Not a very low like mini or micro, not very high or kilo or something like that. And then usually the starter kit comes with 220 ohms for resistors. All right, quick question. Why do we need resistors? Again, LED are light emitting diodes, so they convert electricity to light, but then that electricity has to be controlled. So a for an Arduino board, usually it provides 5 volts. So that 5 volts is kind of big, all right? It will overwhelm the capacity of the LED. So that voltage carries a big resistance. Sorry, rather current. So we need to slow that down just a little bit to prevent damage to our LED. Thus, we need to reduce the voltage. So we are going to use a resistor. So resistor is important, and in all of your future circuits and challenges, do not forget to include a resistor. So the next part is closing the circuit. Notice there are no jumper wires or connecting wires here. We can zoom this in, just click control and then the moving part of your mouse, and then hover it to these terminals. We have terminal 1 and terminal 2. Terminal 1, since we're doing a 5 volt, the default port, like the basic, is to connect it to D13. Alright? And you can change the wire color. I want it to be dark. Alright. Again, your voltage source is going to be this part right here. USB connected to a laptop or computer. And then that will provide the 5 volts. And then all we need to do is complete the circuit by connecting wires. So click terminal, then connected to the anode, and then change the color to turquoise. So anode is the longer leg of the LED. It is usually connected to this side, to the positive side. And then cathode connects to the ground. Right. So the ground closes the whole circuit. Now all that is left is to click Start Simulation. So it can be found right here. As you can see, it's blinking. Right? So blinking is one of, like I said before, one of the first or the most fundamental programs that you need to understand. So it gives you an idea of how a circuit looks like for those of you have might have forgotten the concept of circuit. So it has a voltage source, some wires, resistor, sometimes a switch, and then the load or the other resistor, which in this case is a LED. Now, you can click Stop Simulation and then look at the code. It has pretty much the same as the VEX or the other programming platforms. So this one is in graphical, so you can see colors and shapes, but we will go to text. All right, it'll give you this question, just click continue. And as you can see, it's pretty much the same as the IDE. It's just a blank page and then you literally type in the commands and make sure you still remember the proper punctuations and whatnot. So for void setup, it must be followed by open and close parentheses. So meaning you are setting up the whole program. So this happens before you actually click run. And then the braces are still there. And in this case, it's the 13 digital pin. So that's this part right here. Remember, there's 0, 1, 2, 3, and so on and so forth. And then we place it as an output. So meaning this part right here is where the voltage would go or would originate. And then it will create that path going to the ground. Right? By the way, this is negative, all right? So that's the hot wire. And then it connects to this ground, the positive side. So when there's more electrons, it's negative, and then current will flow from that part, higher potential, and then goes to a region or a terminal with lower potential, which is the positive side. Many of tangents. If you want to recall, revisit those concepts, please check out the PDF for robotics. It gives you an overview of the Ohm's law and basics of uh, electricity. All right, moving on. So for void loop, it says digital write 13 high. So that means high, there's the surge. There's like, all right, I'm giving off energy or voltage for that 13 digital pin. And then for how long? 1 second. Okay, 1000 milliseconds is equal to 1 second. And then that's it. After a second, it will give you this program, digital write 13 low, and for how long do you want it to be low or dim or blacked out? 1 second as well. Thus giving you this sequence: one, 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 lighted one, dim one, and so on and so forth. That's why it says loop. It will be a continuous program. All right, just play along with the figures and numbers here. What if we change it to 100 for the high and then the low 900. So this is like 100, like 1/10 of a second. And then the other 9/10 of a second, it's slow. Observe what happens. So this is like more of a siren or an ambulance or traditional blinking because it's like lit or lighted momentarily, but then it's black or dim for most of the time. Thus, this figures right here. All right. So you can play with the numbers if you want to for blinking. Doesn't matter how long it's lit or lighted and how long it's dark or dim. The condition is it must be blinking. I changed it to 900 and 100. It's lighted for the most part, and then for a brief moment, it's dark. And that's it. You can click this part. And it gives you this overview. So all changes have been saved. And what you need to do now is just click on the Tinkercad icon right here if you want to go back to the previous menu. And then here, I'm doing that. And it will show up here. There, project one, Blink. So this one, you can always go back to it. You can always duplicate it if you want to start not from scratch or move to project, separate folder. You can always tinker your circuit and then you can always export it um, and then share or collaborate. You can have a snapshot of your design. So this will be the process on how you're going to submit it to your teacher. And well, that's it. Thank you so much for listening, and I hope you learned how to create your first program, Blink or Tinkercad. You can always tinker. You can always play around the buttons and then see if you can change the settings for your Blink program. All right, that's it. Until then, thank you.